Hi, I'm Chris from Premier Guitar. We're at the Montreal Guitar Show, and we're talking with Pete Swanson of Dagmar Guitars. He's going to show us a little bit about these very inventive instruments he's got here. Hi, Pete.
Hi,
So, this is your debut show.
this is my first show, my first public display, and been building guitars over the last year, just prototyping out 3 models. I've got a couple more prototypes in my shop right now that are probably going to be on display next year, and I'm just really excited to be here.
You told us yesterday you started off making wooden bicycle fenders, and that's how you came up with the idea.
Yeah, I used to be in the boat building industry, and I had a friend that was doing a special project on his bench, and he was making a wooden urn for our boss's deceased father. And I was just really amazed at when he ripped thin slats of wood at specific angles, he was able to glue them up together and create a vessel, like a vase. And I thought that was really neat how he could make a circular shape out of wood and then sand the hard edges off, and it would become completely rounded. And at that time I was hobbying on the weekends doing balloon tired bicycles, and I had an old Schwinn bike that I added an engine to, and I wanted to do something with the fenders. So his urn kind of inspired me. I looked at what he did, and I just figured out after a few sleepless nights, if I added a step in some high school math and some really precise table saw techniques, that I could add curve in the opposite direction. So I could bend wood in 2 directions at the same time, which with traditional methods would be impossible.
Sure.
So also carbon fiber makes this possible, because you have to think of this guitar as built in segments, and each segment is the shape of a keystone, like in Roman architecture. So there's no forms involved, it's all free-formed with a string of math equations and precise machining. So when you look at the body of a guitar, it's made up of all sorts of radiuses connecting and transitioning into one another. So I would calculate those radiuses and figure out the angles to make up those radiuses. Jigged up a system on the table saw and started cutting pie shapes out. So at the end of cutting, I had about 86 segments, and I started gluing them in sequence, end for end, and I really didn't know if it would be true to the drafting that I had done on paper or what I would wind up with. But obviously it worked out, and I've got 3 to show off for the show. The neck, it was important to me to show that I could go all the way around with this technique. I was originally just going to put a piece of solid wood in this area and do something easy, but no, I decided to finish off the perimeter. So the neck is shallow, and it's got a single bolt, which I access through the end pin jack hole with a custom Allen key. And in the heel cap here, this is doweled and epoxied into the solid material within the curve here, I've got another, just an anchoring bolt to help keep everything down and aligned. So on a traditional guitar, the solid pieces of wood also act as glue surfaces for the top and back plate. In this guitar design, those solid pieces of wood are confined inside the curve of the guitar, which means there is no glue surface in these areas of the sound plates, which makes for a more free vibrating instrument. And all of my necks are lifted off the surface as well. This particular guitar, this is a Western red cedar top that has been finished with pigmented varnish in an antique ivory. The flame maple is cooked, which means when the maple comes out of the kiln, it goes to a second process where it's cooked in a conventional oven for about 3 days straight. The inside cell structure of the wood collapses. The wood actually becomes more dense in the process, more brittle, but it becomes a lot more stable and is not so susceptible to humidity changes. That's okay in this design to use that kind of wood because everything is backed up inside by 2 layers of unidirectional carbon fiber to keep it from collapsing.
Sure.
So once I finish the outside rim, the next step would be to fair the inside out, lay down the carbon fiber, and once that's done, and I know that it's not going to collapse, I start shaving the wood down. So in the 3 rows here, the thickness of the guitar plus the wood plus the carbon fiber is about 4.5 millimeters, and then it flares to about 6 millimeters, where I let in a rabbet and I press my sound plates into that. Every guitar is a one-off creation. It means that I'm not working with the same molds at all. I work with the same math equations,
Gotcha.
but if I'm off just by 1/100 of a degree in my cutting, I get a slightly different shape.
Sure.
Now that so it's very exciting to build, actually, because I don't know exactly what the final shape will be. I'm getting better at predicting it, but I can finish each guitar in the realm of where it should be. For example, these 2 guitars, the lower bouts are 17 inches. This guitar I had great success with because I wanted a wider waist and I wanted a more wide upper bout, and I was able to achieve that on the fly with just figuring out that math. So
That's very cool. So, if people that are interested in Dagmar guitars, where can they go online?
www.dagmarcustomguitars.com.
Easy enough. Thanks, Pete.
No problem.
I'm Chris Burgess. You're watching PremierGuitar.com.